Okay, we're going to start with the notes on section 2-1. This particular day, the notes are going to be a bit interesting. This is going to be kind of the language of geometry. And so we're going to start off with conditionals. These are if-then statements. So there's an example of it right underneath here. If an angle is a straight angle, then it measures 180 degrees. You're going to see a lot of these if-then type of statements, which are again called conditionals. If a figure is a pentagon, then it has 5 sides. A converse statement is basically, even though it says the word converse, it really should say the word reverse. These reverse the if-then statements. So an example, if an angle is a straight angle, then it measures 180 degrees. If you're talking about the reverse of that or the converse of that, you would say, you'd put this part first. If the measurement of an angle is 180, then it is a straight angle. Basically, you just put things in reverse. If a figure has 5 sides, then it is a pentagon. The hypothesis and the conclusion. Whenever we have these sentences, these theorems, the hypothesis is the if portion, and the conclusion is the then portion. So we might say, if it is raining, then there are clouds. If it is raining is the hypothesis, then there are clouds is the conclusion. All right, let's go to number 1 and 2 here. Now what you're going to notice when you do today's work is a lot of just sentences, and it's almost going to be like an English class. So here's number 1. Write the converse. Now again, converse, it's a new word, but really it's almost like reverse. The converse of each conditional. Again, conditional is an if-then statement. And then determine the truth value. Now this is a fancy word for true or false for the conditional and its converse. So here is the original if-then statement. We'll call this a conditional. If 2 lines do not intersect, then they are parallel. Okay, then we're going to write this in reverse. Instead of saying the word reverse, we're going to say the word converse. So if 2 lines do not intersect, then they are parallel. Now we're just going to say if 2 lines are parallel, excuse me, then they do not intersect. And that would be the reverse of it, or we're going to use the word converse. So you take this original if-then statement and throw it into reverse it. Okay, now they're going to ask you true or false, the truth value. Is the original sentence true or false? If 2 lines do not intersect, then they must be parallel. So these 2 pens do not intersect, and they seem to be parallel. But is there any way where you don't intersect and you're not parallel? And that would be yes. You could be skewed. Now it might be hard to notice this, but one purple pen is way above the black pen down here, and so the conditional is actually false. Not all lines that do not intersect are parallel. Some can be skewed. Let's read the converse. If 2 lines are parallel, then they do not intersect. Yes, if 2 pens are parallel, if they are parallel, then they do not intersect. Now this part is true. So one way could be true, the other way could be false. So you got to think about the scenario. Again, the converse of this is false because lines could be skewed. You don't know. Okay, here is a sentence for part B. It doesn't even look like a sentence, but there's an if portion, and then there's a then portion. If x is equal to 2, then the absolute value of x is equal to 2. So we're going to put that in reverse. So we're going to say, if the absolute value of x is equal to 2, comma, then x is equal to 2. So you just flip the if-then portion. And now we're going to figure out true or false. So let's go back to the conditional, the original if-then statement here in yellow. If x is equal to 2, then if I put a 2 here, the absolute value of 2 is equal to 2. Is that true or false? Well, that would be true. Now let's take a look at this converse sentence. If the absolute value of x is 2, then the answer for x must be 2. And this is actually false because x could be negative 2. Because if I put negative 2 in these brackets, it will also equal 2. So this is the reason why that is not always true. Okay? Now this example that I did right here, like proving why this statement doesn't work, or this in the previous problem when I said, well, maybe there's skewed lines proving why it is false, those are called counterexamples. An example when you prove something to be false. So this last problem here, number 2, says show that this conditional is false by giving a counterexample. Giving me an example of when this is not true. So here is the sentence in pink. If the name of a state includes the word new, then the state borders an ocean. So we're basically saying if you are a state with the word new, you must be by an ocean, but we're going to give a counterexample of when this is false. So what state has the word new in it? Well, New York, but then New York is by the ocean because the Statue of Liberty is right by the ocean. So that's not a counterexample. New what? Well, it's not New Jersey because there's Jersey Shores, and that means you're right by the ocean. It's actually going to be New Mexico, which is right next to Mexico. Mexico, of course, is not an ocean. And this one might be a little bit harder. New Hampshire. New Hampshire is not by an ocean. So here, these are considered counterexamples. They do fit the statement, but it proves this statement to be false.